Today is the 12th, yes. Control the gum. A triangle. A triangle is a figure formed by three segments joining three non-collinear points. What's three non-collinear points mean? Not all on the same line, correct. You can't form a triangle if your points are all in one straight line. So you make just a line. So three non-collinear points. What's that?
If it's three segments and you join them together, wouldn't that would be one segment then out of line?
Right, but if we say collinear, that means they do exist on the same line. You might just be picturing the segment, but they are on the same line. They are on the same line segment, and a line segment comes from a line, so the term is used in that way. But I think we're agreeing you can't have three that are lined up. So a triangle, obviously, there's 1 point, there's 1 point, there's 1 point. Connect those 3 points, A, B, C, and you make a triangle. There is a symbol for triangle. So when we name a triangle, we'll go, that's the symbol for it, triangle, and then just name the 3 points in whatever order you want. Maybe you like triangle ABC. Maybe it's triangle BAC. Maybe it's triangle CBA. Any order, just the 3 corners that are involved. So there is a symbol to use, and that's going to indicate that we want that closed shape, which would be different than if I said angle. Angle, ABC, would be just 1 corner, and the other side would be open. But triangle means we've got it completely closed up. Done with notes? We will classify triangles in 2 ways today. One way is by the side lengths, how long the sides are. These are the words that you will use when we classify by sides. An equilateral triangle is a triangle with 3 congruent sides. What does congruent mean? Right. So if all the sides are the same length, it's equilateral. So how would that look? Draw one that has all the sides the same. Close, maybe? All 3 sides are the same length. Maybe they're 2 inches, 2 inches, 2 inches. That's the idea of equilateral. Isosceles triangle is a triangle with at least 2 congruent sides. It could have all 3 congruent, but if it's all 3 congruent, we really use equilateral to describe it more specifically. So isosceles is used more often when there's 2 sides congruent, but the definition says if it has at least 2, then it's isosceles. So an equilateral triangle is a subset of isosceles triangles, if you were making a Venn diagram. Isosceles triangle, let's make kind of a tall, skinny one. Those 2 sides are congruent. Let's make one that's stretched out more. Obtuse angle. But I'm trying to make those 2 congruent. Isosceles. At least 2 congruent sides. Scalene is a triangle with no congruent sides. They're all different. These can look a lot of different ways. Try and draw one. So how would I mark that they're all different? If I were putting numbers on them, I could say this one is 3, this one is 10, and this one looks a little bit longer, 12. They're all different. If we were putting tick marks, you'd have a different marking on every side. Students usually get isosceles and scalene mixed up, if you're mixing something up. So how are we gonna remember? What's something you can think of to help us? Isosceles has at least 2 congruent sides. Scalene has no congruent sides. Isosceles what? Has a lot of S's. So it has more that are the same. Okay. Isosceles has a lot of S's, so there's possibly 3 sides congruent, at least 2 sides. These 2 sides and maybe the third one.
Isosceles has 2 E's.
2 congruent sides, but scalene does too. Maybe a different letter. The L's maybe are, let's see, I's. I guess that's an I and that's an L. That doesn't work. Let's go by that. Yes?
If you split it into syllables, the first one has 3 and the second one has 2.
Isosceles. 3 parts to it, so it has more sides congruent. I don't know if we're saying anything that will help you remember, but scalene has no sides congruent. Isosceles has at least 2 sides congruent. Equilateral has all 3 sides congruent. Looks like everyone's done with those notes. Okay, so use those words. Grab your marker board. What type are each of them? Isosceles, equilateral, scalene, isosceles. Question on any of those? No? Okay. Let's classify by angles. Those go down at the bottom there. We'll use the marker boards in a little bit, so don't put them too far away. An equiangular triangle is a triangle with 3 congruent angles. Triangle with 3 congruent angles. Could we make the angles 90s? Triangle with 3 90-degree angles. Try and draw that, it's not going to close up. That would be a square and you'd need 4 of them, wouldn't you? Not 3. 3 angles that are all the same. Has to look something real close to this. So I'm going to mark, I mean that angle is the same as that one and that one. So I mean for all of them to be the same. Equiangular. Now the last screen there was equilateral. They don't mean the same thing. Equilateral means the sides congruent. Equiangular means the angles congruent. Acute triangle, a triangle with 3 acute angles. How big's an acute angle? Okay, less than 90 degrees. So somewhere from 0 degrees up to, I guess, but not including, I don't know how I want to write it. So the measure has to be between 0 and 90 to be acute. So the one I drew up there is an acute angle, or acute triangle. All the angles are less than 90 degrees. Not always are they all the same. So there's one stretched out a little bit further. So all of these angles smaller than 90 degrees is an acute triangle. We'll talk about the degree measure in this lesson, so we'll get there. Right triangle. A triangle with 1 right angle. As some of you just thought about, you can't have more than 1 right angle. Otherwise, it's not going to close up. It could make like a U or a football goal or something, but it doesn't make a triangle. So 1 right angle, mark it with a square corner or right in the 90 degrees so that you know what the angle is. I'm going to extend that up a bit. That help? And then an obtuse triangle, a triangle with 1 obtuse angle. What's an obtuse angle? Yeah, more than 90. Technically, but can't be 180. So it's between 90 degrees and 180. So it's a wider angle. Can't have more than 1 because that would be even worse than 90 degree angles. They really open up. So 1 right or 1 obtuse angle. There's my big obtuse angle. And we'll just finish making it a triangle. If that doesn't look obtuse enough, maybe you could turn it a different way. There's the obtuse angle. Close it up to make a triangle. Okay, let's do some classifying by the words right, let's see, what was the first one? Equiangular, acute, right, obtuse. Okay, so grab your marker board again. That wasn't very interesting. I'll make a new set. Okay, number 1. What kind of a triangle? Classified by angles. I think I'll do more than 4 actually. Remember this one. See to the bottom. It'd probably be easier if you just hang on to them and I read them. That's enough to read through and try and show. After we go through these, John erase it. All right, first one was obtuse, second, third. I think that's obtuse. This looks like a pretty wide angle. Obtuse, 4, equiangular, 5, acute, and 6. Right. Okay, now let's combine them. Okay, so if I put some markings like this, now you can add the words. So you have described by angles and sides. So number 1 is an obtuse scalene triangle. Number 2 was a right isosceles triangle. Number 3, obtuse isosceles. Number 4, equiangular and equilateral. 5, acute isosceles. And 6, right scalene. I didn't even mark that last side. It's not the same as the others. So you can classify by both sides and angles. All right, question on that terminology. Okay. I want you to try and draw me a picture of the triangle that I'm asking. Okay? Some of them are going to be not possible, so watch out for those. Okay, first I want you to show me on your marker board an acute isosceles triangle. Or write the word not possible. Acute isosceles. Show me if you're having check. Good. Haven't found any that I thought I needed a protractor to measure. All right, so that one was possible. All right, and it kind of looked about like what I drew, I guess. Isosceles, though, you needed 2 sides congruent. Okay, let's draw a right scalene triangle. A right scalene triangle. This is the right triangle. Not scalene. It is possible. And Ben, what's right mean? Okay, and what's scalene mean? Scalene doesn't have to do with the angles, the length, the sides. The sides are not the same. So can we make a right triangle where the sides are all different lengths? We haven't talked about measurements on them too much, but Ben, do you remember using 3, 4, 5 for a triangle? Okay, that would be an example. If this side were 3 and this is 4 and this is 5, those sides are not the same length, and it's a right triangle. So that one was possible. Okay, number 3, draw me an obtuse right triangle. Right, obtuse, obtuse right. Keep it in the bag, that way if we run out. No, that one is a right triangle, but it's not obtuse. Hey, it's not possible. If you make a right angle, to make an obtuse, then in addition to it, you'd have to maybe go out wider from one, and now you've run out of sides. Can't close it. So that one was a not possible. All right, some terminology about triangles. The corners are vertices. So a vertex of a triangle is a point that joins 2 sides of the triangle. So this point right there is a vertex. Point A is a vertex. Point B is a vertex. Point C is a vertex. Each one's a vertex, plural vertices. So when you name a triangle, you're using the vertices to name them. So what is the vertex that joins segment AC and segment BC? The vertex that joins them is C, correct. And you could really tell just by looking at the names of them. What's the vertex that would join segment BA and segment CA? A would be that vertex. Okay, next screen. The side across from an angle is called the opposite side. The side that's across the triangle. That's its opposite side. So I'm going to give you a triangle here. We'll make an obtuse triangle. We'll call it RST. It says name the side that is opposite of each angle. So if I'm looking at angle T, what one is it opposite of? What side is it opposite of? Segment RS is the side that's opposite of angle T. If I have angle S, that is opposite of segment RT. And angle R is opposite of segment ST. I need a thumbs up or down because I didn't hear a lot of voices. Tell me whether you understand what we're talking about for opposite. Thumbs up or down? Tell me so I know whether I need to explain some more. All right, we got a few that are kind of iffy maybe, so let's do a little color coding. Angle T is made up of these two sides, so the other one is opposite of it. So this side, RS, is opposite of angle T. If I go with angle S, in green, this side and this side make angle S. So opposite of angle S would be segment RT. Is that helping? Okay. All right, that's the idea of being opposite of it. Okay, triangle sum theorem. I think some of you knew this idea. The angles in a triangle have to add up to a certain amount. What's that amount? 180 degrees. The sum of the measures of the angles of a triangle is 180 degrees. So that's one reason you can't have 3 right angles in a triangle. 90 plus 90 plus 90, that's more than 180 degrees. If they were all the same, if we had an equiangular triangle, they're all the same and they have to add up to 180, how big would each one have to be? Have to divide 180 by 3 and you get 60. So if they're all the same, they're going to be 60, 60, 60. What if one of them's 90? If you had 2 90s, you would not make a triangle, correct. But if I do have a triangle and one angle's 90, can you tell me anything about the other two?
They have to equal 60.
if I had a triangle and one angle was 90, do they have to be 45 and 45?
No,
No, not unless they have to be the same.
but
Now
that
let's
they equal
look.
90.
Okay, if this one is 20, the other one has to be
70.
70. If this one was 10, that would be
80.
80, 30, 60, 45, 45. So these two have to always add up to 90 if there's already 190. Because all three have to be 180. If you subtract 90 off, what's left for the other two totals 90. So we're going to do some where you try and find the missing angle measure. I made a big obtuse one there, 140 degrees. I'll even tell you this one is 30 degrees. How many degrees is the last one?
10.
10. Because they have to add up to 180 degrees. Just doing some examples. So that's what I was going to have you do here. Okay, let's do a few more. Grab your marker board. Find the missing angle measure. That's by missing angles. Less than 10 degrees? Sure, you can. Can't be less than 0 degrees, or it can't be 0 degrees, but it could even be a half of a degree. Really, it'd be hard for me to draw one like that, but sure you can. So just what you're thinking, let's see, here would be a real narrow angle. Now maybe that's only 5 degrees. I mean 5 degree sign. Okay, and let's say this one's even 90. What's this last angle?
85.
85? So yeah, you can have angles that are less than 10 degrees. It's not a very big angle. Okay, so our answers were 30 and 40, and then we talked about another one. Okay, there are a couple corollaries. They are things that I talked through with you. What's a corollary? A statement that can be proved easily using a theorem. So these two come easily from the triangle sum theorem. And I asked you them just a little bit ago, and you told me the right answers. One of them is going to talk about equiangular triangles. So easily we figured out if all the angles in the triangle are the same, and now we know they have to total 180, how big was each one? All three angles are the same in a triangle.
60.
They'd all be 60, yes. Another corollary is the one that I asked you about. If you have one angle 90, the other two have to add up to 90. What are two angles called that add up to 90 degrees? Complementary. So that one's going to talk about the two angles have to be complementary. Got the definition of a corollary? Sometimes I refer to this as a baby theorem because it's not a big enough idea to just be on its own. So it comes from another theorem easily. Got the notes? So here's the one about the right triangle. Corollary to the triangle sum theorem, the acute angles of a right triangle are complementary. Right triangle. Notice we don't have any obtuse angles because we know our total would be too big. The acute angles are always complementary. So in this one, angle A and angle B always have to add up to 90 degrees. You were really telling me that just a little bit ago when you were giving me the measurements. If this one's 70, the other's 20. If we did 80, it was 10. If it was 45, it was 45. Those two acute angles always added up to 90 degrees because the other angle's already 90. So to add up to 180, that would be the situation. That one comes from the triangle sum theorem, very quick and easy. Got it down? Hold on. All right. And we did a lot of those. Let's take a look at this one. Let me see if there was another theorem. No, okay. How would we do this problem? Because it's got more variables in it, not just numbers. Ben? Exactly. He's adding up all the angles and has to total 180. So we've got 2 and 1 more and 3 more. How many x's? 6. 6x plus 12 has to equal 180. Subtract 12. 6x has to equal 168. Divide that by 6. 28. Okay, so that's the value of x, and it says, and the missing triangle angle measures. So this one is 28. This one,
56.
2 times 28, 56. And 3 times 28 plus 12. Add 12, you're right, 96. And how could I check to see if that's right?
96 plus 56 plus
Those three
180.
angles should add up to 180 degrees. Question what we did to set it up? Hopefully the solving comes back to you. And as you saw this last example, how will we find x and the missing angles? Okay, so a few others. Sam, you know how to do this one? Exactly. 3x plus 2x plus 90 has to equal 180. Did anyone have a different way to set it up? Carrie?
3x plus 2x equals 90.
Okay, you could just do those two equal 90. Because if I would subtract 90 right here, even without combining that, we would get what Carrie mentioned from what Sam started us with. All right, 5x equals 90. 90 divided by 5.
18.
I think it's 15. 18. 18. So our angles, 2 times 18 is 36. And 3 times 18, I think it's 54.
Yeah.
And then when you add the 90, you get 180 total?
Yeah.
All right, there are some other things in the second section, but we'll tie that into tomorrow's lesson. So let's do some from those first two sections. Remember the first section was just classifying, is it acute, right, obtuse, straight? Get those words out. If it says classified by sides, don't call it acute triangle. I don't think we need to. There might be some things that are close and you might wanna measure. But I think we could probably get by without them, especially after going through a few of the first problems. Alright, so let's use, I'm sure that on those classifying things, you can get a lot from that first page done in a quick 5 minutes.